slides for today are available on track. And the topic is allocating resources to the project. And you can find, or if you're interested in reading your textbook, this is material that is covered in Chapter 6, which has the same title, Allocating Resources to the Project. And in terms of the course objectives, this material will cover the last two objectives. And we're going to be doing some stuff related to Microsoft Project and also related to analyzing and creating network diagrams to identify opportunities of reducing the project lead time. And actually that objective is mostly what we're going to cover today. So we're going to discuss a new strategy. Any questions, comments? Seeing some people talking. So in terms of, if you have the homework that you haven't submitted yet, you can wait until the end of the lecture. I will pick it up at the end. And in terms of the material that we're going to cover today, it's very related to objective number 5 of the class, which is creating and analyzing network diagrams to identify opportunities of reducing the lead times of the project. So the agenda for today, we're going to discuss expediting the project, resource loading, resource leveling, and allocating scarce resources to project by using some priority rules. We already did some of the resource loading when we discussed Microsoft Project in class. We were looking at the calendars of the resources, and we were trying to not to occupy some of the resources when they are not available, and so on. We're going to touch on that one more time today. So in this lecture, we consider the problem of allocating physical and human resources to the project. And at the end of this lecture, you should be able to selectively choosing which activities to crash and by how much. So crash is the strategy that we're going to look or learn today that will help us to reduce the lead time of the project. And the second objective or learning objective for this lecture is to determine the minimum cost for all possible project completion times. So let's talk about expediting a project. So again, we're going to refer back to the two network strategies or diagrams that we learned on our previous lecture, which are the PERT and the CPM. And the rules of standard practice apply when you're trying to expedite the project. The normal task duration estimate is made with the standard practice resource usage. So remember in our previous lecture we were using estimates for pessimistic, optimistic, and in normal usage. Today we're going to just focus on one of the estimates, which is the standard practice resource usage. It will be the normal estimate. A second estimate referred as a crash duration. It's made based on the resource required to expedite the task. So there will be some tasks that you can complete in more faster if you add more resources or if you bring a different technology. So that's what we're going to call these, when we are trying to crash these activities, That's what we're trying to do. We're trying to find ways to reduce the time that is going to take to complete those tasks. You can do that with multiple ways. You can add more resources. You can use a different strategy. But what you need to know is by changing the strategy that you had, you're going to incur an extra cost. And that's what we're going to evaluate. How good is the cost in terms of when you're trying to expedite these activities? So, more resources of the type already used might be added. So we are trying to expedite these activities. We're going to add more resources. When you're making the estimates for crashing or for reducing these completion times, it is important to make sure excuse me. So make sure that the resources required are available. So you're not just gonna say, okay, I'm gonna add more resources and that's gonna help me to complete the task in faster. You're gonna have to make sure that you have those resources available by the time you need them. If you don't have the resources, then you're not gonna be able to complete on the estimated time. So for this strategy, we're going to be focusing on the critical path, which is the longer that it's going to take for you to complete the project. Okay? So, but some tasks cannot be crashed. For example, one must not assume that because it takes one woman 9 months to carry and bear a child, that 9 women will accomplish the same result in 1 month. So it will not be possible. So that's what we're trying to say. There will be some activities that even though you can add more resources, they're not going to be able to reduce the completion time. And we're going to use this example to explain what we're trying to do. So here we have a project that has 5 activities. We have the precedence activities, and we have the duration in terms of the norm, which is the typical time that it's going to take to complete each task. And also we have a second duration that is called the crash duration. And as you can see, there's a difference in the time, and obviously the crash time is going to be less. Okay, so for instance, activity A, if you use the norm time, that's going to take you 3 units of time. But if you decide to crash the activity, it will take you 2 units of time or days. We also have a cost associated with each duration. So for norm, for example, activity A, it will take $40, and for the crash duration, it will take $80. There's also more information here in terms of these 2 activities. For activity B, partial crashing is allowed, meaning that you can crash one day at a time. And activity E says partial crashing not allowed. So it is the normal duration or the crash duration. You cannot cut the duration one day at a time. So it's going to be either 3 days or 1. On the other hand, for D, you can take 3, 2, 1. So one crash duration is marked with a single asterisk. For this activity, the task may be carried out in normal time or crash one day at a time. For the activity that is marked with 2, in this case, the duration must be one or the other. It cannot be broken down to 1 day segments. Okay, so we're going to refer to this table throughout the example. The activities are going to be charged at the cost per day. Which we call the activity slope. And the activity slope is computed as follows. This is going to be the slope, which is going to be equal to the crash cost minus the normal cost divided by the crash time minus the normal time. So we're going to compute the slope for each one of the activities using their information about the crash cost, the normal cost, the crash time, and the normal time. And that slope is what's going to tell us which activity is the cheapest one and the one that you're going to select to crash first. So we're going to be sorting these activities based on this slope or the cost per day. A given activity may have only 2 or 3 technically feasible durations. And if an activity cannot be split into one day segments, the cost will be as indicated. So that's what I explained in terms of the norm and the crash cost. Any questions so far? This will make more sense with the example. So if we draw the network for this project, this is how the network will look like. We're going to have a couple of dummy nodes here just to make things or to illustrate things easier. But right now, the normal schedule will give you 8 days for completing the project, and it's going to cost you $120. We also, this is the same table that I showed before, but now you have an extra column that is showing the slope for each one of the activities. So that slope is telling you the cost per day. So for the first activity is going to be $40, the second activity is $60, and so on. And that was computed using this slope. Okay, so remember, we're going to use this cost per day to decide which activity are we going to crash first based on this cost. We want to minimize the cost of crashing the project, so that's why we're going to look at the minimum cost to decide which of the activities to crash first. So to crash a project, follow two simple principles. The first one is to focus on the critical path. And that makes sense, right? Because if you reduce one of the activities that is not in the critical path, chances are that you're not going to be reducing the duration of the project. When trying to shorten the duration of a project, crashing a non-critical activity will not influence the project duration. So for instance, we have that the critical path here is ABE, which is going to be here, here, and here. So if you crash this activity Z, that will have no impact on the total duration of the project. So the second principle is when shortening the project duration, select the least expensive way to do it. So again, we're going to focus on the critical path. We're going to look at the activities cost, and we're going to choose the one that is less expensive, and we're going to start from there. So if we look at this network one more time, we're going to start trying to crash the project one day at a time. So for instance, we can reduce the duration of the project, or we're going to try to reduce the duration of the project by 1 day. So right now it's 8 days. We want to reduce by 1 day, so the total duration should be 7 days. If we look at the network and also here at this information, activity D can be partially crashed for $30. So that's this information, but it's not in on the critical path. And will not shorten the project. So even though it's one of the least expensive or the least expensive one based on this slope of the cost per day, since it is not in the critical path, we are not going to use that one. Now, activity E involves a technological discontinuity, which means that adding a new machine will shorten the duration, but you can either choose three days or 1 day for the duration of the project. It will be one or the other. And must take either 3 days to complete at $10 or 1 day at $80. So that's what we call a technological discontinuity, that type of activity. So that's the information we have for activity D and E. So if you're looking at crashing the project by 1 day, activity E will not be an option because you can shorten the project by 2 days. You don't have the option of shortening by 1 day because for that activity you can have 3 days or 1 day as your total duration. Yes, sir.
So when you have the multiple day options like that, you use the slope formula to determine which one is the most efficient.
The cheapest one, or the one that is less expensive.
Right. So if it'll be like, say, if you have 2 and 3 days, it'll be a certain amount of 2 days.
You will start shortening by 1 day, and then this is gonna be the cost per day. So if you shorten by 1 day, if you use activity A, that's gonna cost you $40. But you can also, actually for that one, you can just cut by 1 day because you can go from 3 to 2. But for instance, activity D gives you more.
I guess kind of what I'm asking is why you wouldn't just show up.
Well, because this is basically, you don't always need to shorten the project that much. It's going to cost you more. It's going to cost you more at the end. So if the client wants you to cut the project, let's say, for a couple of days, you would not push the project by 5 days because it's going to cost you more money. That will be the answer. Any other questions? So, but in the example, we're going to go all the way. We're going to push the project up to the limit, which is going to be 4 days, okay? So, the decision about which activities to crash depends on how much we need to reduce the duration of the project. And that basically answers the question that you were asking. Okay? So we know that we're going to incur on an extra cost. So we want to satisfy the constraint, but we don't want to incur on additional costs if we don't have to. So to reduce the total duration by 1 day, we must reduce the time required by one of the activities along the critical path. So again, we're going to look at the critical path. We have A, B, and E. So we're going to look at those activities. So inspecting the table, the critical activity that can reduce at the least cost is activity A. And this will add $40 to the project cost. Of 120. So we check the table again, activities A, B, and E. The less expensive one is A, so we get a direct to patch activity A by 1 day. And shortening that activity by 1 day is going to cost us $40. So, cracking 8 is the lowest cost and therefore is the preferred option. So if we cut that by 1 day, now we have a 7-day schedule and it's going to cost us $160. And you see now that the network will go from 1 day to 7 days. So we add $40 to our cost, but we shorten the total duration of the project by 1 day. Notice that crashing A also shortens AD dummy. So you're shortening this first activity, and you know that that activity will influence the rest of the network. So if we shorten this one, that will also reduce the duration of this path. So those extra paths are gonna be reduced by 1 day as well. Okay, so if I ask you to reduce the project by 1 day, that will be the way to go. But now the next question is, suppose the project must be crashed by 2 days. What are the options? So again, we're going to focus on the critical path. So our critical path again is A, B, and E. We can crash activity E for 2 days. That will cost you $70, which is this activity here. But path A, B dummy will have a 7 day duration, must be also crashed by at least 1 day. So if you crash the critical path using activity E, then that will make this path AD dummy the critical path, and that will give you a total duration of 7 days. So if you want to shorten the project by 2 days, making it 6 days duration, then if you use activity E, you also have to consider the duration of the path AD dummy. So instead of that, we're going to choose D, which has a cost of $30 a day because it is cheaper than A, which is $40. So the total cost of crashing is 100. We're going to crash using E and also D. And if you add those two, that will be 70 plus 30. So the total cost of crashing is $100, and the total project cost is 120 plus that $100, and it's 220. So now the total duration will be 6 days. And we crash the project by 2 days. But as you can see, the more you shorten the duration, the most expensive the project becomes. Yes, sir.
So now I'm shortening it by that, now we have two critical paths. because
Yes, sir. Yes, we're going to have both of them at critical path. That's correct. Any other questions? Okay. So again, we're going to go all the way to 4 days. So we did that for 2 days. Now, crash the project by 3 days down to a project duration of 5 days. And I will give you some time to think about that, and then we're going to discuss it. So check the table information that we have, check the network, and also you can use these notes as a reference. That will give you an idea of what we're going to do to crash the project for 3 days. So I'm just going to give you a minute to think about it, and we're going to discuss it. Okay, So now we want to shorten the project by 3 days. So again, we're going to focus on the critical path. Our critical path is A, B, and E. So we can start by crashing E by 2 days, and that's going to cost you 70. And A or B by a day. We're going to choose A because it's less expensive. So choose A, which is the cheapest. For an additional cost of $40. So what we are saying is we're going to shorten this from 3 to 1, and this one from 3 to 2. And those are the 3 days. We have a 2-day duration. B is 2, and E is 1. So that's going to give you 5 days. Now we're going to look at the other critical or the other paths. So if we look at this leaves D to be crashed by 1 day for another $30. And if you add all the extra costs for crashing this project by 3 days, that's going to result on the original cost of $120 plus $140. That's going to be a total cost of $260. So now we have our total duration as 5 days. A is going to be 2 days. And D is going to be 3 days. So our total duration is 5 days. You're going to go one extra step. I'm going to try to cut the project duration to 4 days. And we're going to be using this same strategy that we just defined for the 5 days to cut the project by 1 extra day. So only B and D can still be crashed, so we crash each one by 1 day for an additional cost beyond the 5-day schedule of 60 plus 30, and that's going to be an extra cost of $90 for a total project cost of 260 plus 90, which is going to be equal to 350. So if you decide to crash or cut the project duration by 4 days, your original cost was 120. You almost went 3 times the total cost to be able to reduce the project duration by half. Okay, so as you can see, the cost was increased by 3 times, even though you cut the project duration by just a half. Any questions so far? Okay, so in terms of crashing a project, the cost side, the graph shows the time cost relationship of crashing the project. So you start with the cost on your y-axis and the duration in your x-axis. So you start with the largest duration here, 8 days, and your cheapest cost, which was 120. But as you start decreasing that duration, that total duration, you see how the costs start increasing. Okay, so that graph gives you an idea of how that cost-time relationship changes. And if you look at the slope of that curve, very steep, right? So it's not a one-one relationship. So when you start decreasing, the cost will start increasing at a higher rate. Okay, so next I have a question that I want you to answer in groups. So you can work with, this is going to be your lab number 4. So you can work on your case study groups, or, yes, I think case study groups will be better. So if you can join your team for a couple of minutes and try to answer this. So I want you to refer back to what we discussed in class in terms of the trade-off. Do you remember the 3 elements that were considered in the trade-off for a project? We show a table, we show a graph. There were 3 of them. Yes, time is same as schedule, cost, and also the requirements from the client or deliverable. So I want you to refer to that and basically state or describe the fundamental trade-offs when deciding whether to or not to crash a project. So which of these 3 elements are going to be affected when you're trying to decide whether or not to crash a project? Doesn't have to be a long answer. Just state which elements and what.
I was wondering on the time will we have to what do we do? Crashing it about 2 days right here. I was wondering because we did crashed it E for 2 days, which you have 70s, and then D for 30. Well, if it was $40 per day, could you just not do A twice, crash it there twice, and it'd be
Yeah, but if you do that, that's going to cost you $80. So it will be 40 per day.
So that
will be more expensive than 70.
Well, I thought it would be 70 plus a 30, it'd be 100.
Oh yes.
So
70, but remember you can for A, you can only crash by 1 day.
Oh, okay.
So
this
you
is
can
what
go
that
from
means.
3 to 2. Yes.
Okay, so okay, I gotcha. So this technically is just
that's the minimum that you can go.
The subtraction of these 2.
Yes, it's 1 day.
Okay, and that's basically what all of them is telling you how much we can cash about. Okay, thank you.
Yes, sir.
Sir?
Yeah, you don't have to overthink the question. I think it's kind of obvious. I just want you to think about it. It's just and state it in your answer.
Even though you're crashing the project, the same results are still going to get delivered.
You're going to get the same deliverable.
Not like because crashing the task.
No, you are not messing with the requirement.
The first I was like, well, how's the customer going to be happy? That's just, you're still doing everything. That's just ridiculous.
Exactly.
Well, yeah, so just go by a certain term, I'll start that.
That's accurate. That's
Just like Sometimes it's just sometimes it's happens like not one source of
Okay, I'm gonna give you 2 more minutes.
Yes. Is there any way I can finish the anymore? Like, you already told us to use 3.3. I use 6, like, that's
Oh.
measurements.
Yeah,
And
I
then try to
can
change it.
just ask me at the end of the lecture. I'll give it to you, and
Okay.
then you can fix it.
Okay, thank you.
And then submit it by this afternoon. I'll be
Yeah, okay. Thank you.
you can have like you can have 88. That 25. Where 89. So that's what I'm saying. You're naming that. Basically, we're gonna need 8 now.
Well, the only grade I have, the only grade that I would be on that last week is 9. Someone mighty well and someone. What's that?
So I have all the labs. Do I have all the labs? Right? Okay.
Apparently won't be.
Okay, so let's get back to the lecture. So let me answer the question for you. It's again very straightforward. You're considering 3 different objectives every time we look at a project. So we are trying to satisfy the requirements of a customer, but we also, the project is going to have certain requirements that we need to accomplish. We also have a limit in terms of the money that we have available, and we also have a time limitation, and that's why we define a schedule. But in terms of crashing a project, the fundamental trade-off in crashing a project is between the schedule and budget. So we are assuming that we are not changing any of the requirements of the project, and when crashing the project, we are just trying to deliver the results in less time, but we know that by doing that, by crashing each activity, we're going to incur on an extra cost, which is going to be affecting our budget. So specifically, entails employing additional resources which is related to your cost in order to reduce the project completion time. Any questions? And those type of questions sounds very good for the exam. Just throwing that out there. So if I say something like this, you should expect something like that in the exam. Any questions? Okay. Can I move to the next? Okay, so now I'm going to transition to a different topic. It's called fast tracking a project. And this is used primarily in the construction industry. And basically what it does is that design and planning phases of a project are not completed before the building phase is started. So what we are going to do here is just overlapping some of these activities. Sometimes you want to complete and get started specifically for designing and planning, but there are certain things specifically in construction that are straightforward, that are going to be the same for each type of building. So for example, you have a building, you want to start with the foundation, so that will be defined already, even though it's not already defined in your design and planning. So the construction company can have an idea of how long it's going to take and what resources are required. So we're going to letting them overlap to reduce the project duration. So as I mentioned, for many projects in construction and maintenance, a large proportion of the work is routine. In this case, fast tracking rarely causes serious problems. Now, in terms of project expediting in practice, this can occur in 3 different ways. The project manager may know ahead of time that this is a time-critical project. And will need to take steps to finish the project as early as possible. The second way, the project manager may get the work during the execution of the project that the due date has had to be moved up. And the third way is something happens during the project to delay some activities so that the due date is going to be missed. So these three ways or situations can force you to try to expedite the completion of your project. And those are the three scenarios that you will find mostly in practice. So if you end up trying to complete your project in or crash your project duration, is because one of these three things might happen. So I also want to discuss some of the opportunities when you need to shorten the duration of your project and the project is already on the way. So I will advise you to focus on the critical path and see if there's any way to shorten it And one of the strategies that you can use is to see if you can crash some of the activities. Request permission to use some of the contingency time. So if you have budgeted some extra time to complete the project, then you can request for permission to use that time. Pull resources from less critical activities with a surplus, or to apply to more critical earlier activities. So if you know beforehand that you're going to have an activity that is not due with a specific due date, you can try to pull some of those resources and try to expedite some of the activities that are more critical. Try to shorten or even skip certain steps like testing, documentation, or training. And this will be like a last resource. I mean, these three things are very important, but if you want to, if you are in the need to cut the duration of the project, you can also try to avoid some of those three things. And postpone activities that involve non-core team members or other stakeholders. So if those activities are going to be adding time to your project, but at the end are not going to, what they're going to do is just increase the time duration of your project, those might not be needed right away, so you can postpone them after you are on track one more time. Okay, so I'm going to stop here and I'm going to pass the exams. I would like to spend some time discussing the exam in case you have any questions.